Herstein's Abstract Algebra, 3rd edition, Chapter 2, Section 1, Problem 10. If G is the group in example 6, find all the elements of G that commute with this element t sub 1 comma x. So I'm saying commute because when we have this equation where we can switch left and right multiplication of an element, that's what we call commute. And then this t sub 1 comma x, where we let x be any real, is really a subgroup of G. So this element here is really representing a bunch of elements of G, all of the elements of the form t sub 1 comma x, and we're looking for everything in G that commutes with those elements. So G is going to be this set with this operation. So the set is all the mappings of this form, AR plus B, where we let A and B be any real numbers. And then our subgroup is just when A equals 1, right? That's what this means. So this is A equals 1 and B equals X, but B would just represented any real number. X represents any real number. So that's where this is coming from here. That's why we know that these are members of the group X, or the group G. And then we're also, in order to find this group, we have to be given the group operation. And this is how we combine two elements of the group. All we need to know for this problem is what a group is, and there is our definition that we've been working with. Now let's look at how to solve this problem. So we want to look at what will make this equation true. So if we call this the left-hand side of the equation, and we call this the right-hand side, then all I'm doing here is solving for the left and then solving for the right, and then seeing what it will take to make these be equal. When we approach this problem, remember what we're being asked for. It's which elements of G. So find all the elements of G that satisfy this. So our answer is going to be of the form, what do we need to do to A and B to make this equation hold? Can A and B be any real number, or do I need to restrict what values A and B are allowed to be in order to make this equation hold? So we see that the left-hand side, just by applying our group operation, which is given to us, equals this, t sub a comma ax plus b. And then similarly, again, applying our operation, we have that the right-hand side is t sub a comma x plus b. So when do these two always equal each other? That is what we're asking for. What restriction do we need to impose such that they always equal each other? And we can see that a needs to equal 1, right? X is allowed to vary over every real value. And in order for this equation to always hold, we need x to equal 1, which means the answer to our problem isn't x equals 1. The question was, which elements of G will satisfy this equation? The elements of G come in this form, t sub a comma b. So our answer is t sub 1 comma b are the elements of G that satisfy this equation. Thanks for watching this video. I hope you enjoyed it. If you have any questions about this problem or you would like me to look at a different problem, make sure to leave a comment below.